Welcome to Lesson 30. We'll now investigate the solution of a maths problem. There's nothing special about the one I've chosen. Most students would consider it to be very easy. That's important if we want to extract an understanding of what's underpinning the calculation. The reason we're looking at this solution is to identify the essential steps which take us from a problem to a solution. I'm taking this example from a topic we haven't mentioned before. We will actually return to it later in the program and then develop its ideas in more detail. Remember, the answer is not important. How we get to it is. And we want an understanding of that journey that is transferable to other problems. The 4 brackets in the diagram below contain the main structural parts of the problem. The dots represent where other words could be included without changing the problem. So even in a much larger question, these 4 components would have to be present. So in its simplest form, we have find the width of a rectangle with an area of 6 square centimetres and a length of 3 centimetres. We begin by identifying the keyword, which is the central concept in the problem. Then we refine this awareness by identifying the setting. A keyword is what most courses would view as a topic heading. So here, our analysis finds the keyword is area. The analysis also indicates that the setting is a rectangle. So from the sections of school courses which refer to areas and rectangles, we can extract the relevant formula: area is length by width. You'll notice here that I've represented the summary of the school courses in the form of a small database. I would recommend you consider that type of structure for your revision basis. So we have a combination of keyword and setting leading to a formula which will begin our formal calculation. Notice that the formula mentions the length and width, which are also mentioned in the problem. We now go back to the problem to see what data it supplies. These values replace symbols in the formula. So the question was clearly, what is the width? That is the unknown. Its symbol will not be replaced. The data supplied was area as 6 units and length as 3 units. So they are replaced. Notice that after we've detected and used the data, the remaining symbol in the formula matches the unknown in the problem. Now that we have a mathematical equation containing one unknown, we can easily transform it into a statement highlighting the required value. So we take the equation 6 equals 3 times w. We have to shift the 3 away from the w. Its process will reverse, so multiplication becomes division, and 6 divided by 3 is 2. Attention to the detail guarantees an accurate calculation. If we put the previous 4 pages together, we not only have the solution to this problem, but we also have an overview of the logic, which will be relevant to any maths problem. So here it is. We are going from the problem through our analysis to give us an equation to process which leads to an answer. The structure is independent of the problem. It only supplies the finer details in this case. The sequence of logic will apply to any maths problem. Different topics simply present different terminology and introduce different formulas. We'll look at a couple of other examples which are not too far removed from this one. So for the question, what is the area of a rectangle 4 centimetres wide and 5 centimetres high? We have the analysis. Keyword is area, setting is rectangle, unknown is area, and so data must be width and height. The solution is our 3-step process. Because the unknown is already by itself in the formula, the area equals. We do not have to shift any numbers, so we just tidy up by evaluating the value of 4 times 5. So there is the minimum amount of calculation to solve this question. The next question contains the same keyword, but a different setting. What is the area of a triangle 4 centimetres wide and 5 centimetres high? So area is the keyword, the setting is a triangle, the unknown is the area, the data is the height and width. Because we have a different setting, our formula is not the same one that we had previously. It is similar, and that is important to observe, but it is unique because this is the formula for a triangle. When we substitute the numbers and tidy up, we get an answer. But just remember, the unknown can be any of the things in the formula. A related question could ask to find the base width. Another one could ask to find the height. These questions would be based on the same 3 sets. These questions would be based on the same 3 numbers: 4 centimetres wide, 5 centimetres high, and an area of 10 square centimetres. So all of this means that before you even begin working on a mathematical problem, you should already have a detailed awareness of how to find its solution. All you have to do is find a few special details and rearrange the mathematical statement they lead to. So here is a general solution that applies to all mathematics problems. The question is calculate something associated with something which has certain characteristic features. These would be represented by numbers. So the analysis of this general question, the keyword, the setting, the data. So there will be a formula of some type. Maybe it involves multiplication, as in the case of the rectangle. We substitute the information the question supplies. One of these will not be replaced. And then we tidy up. This may take 1, 2, or 3 lines. We get a solution. The only requirement is somebody has investigated the setting and determined the appropriate formula. If nobody has done that, then you can do that yourself. The next section of this course will investigate some new topics in detail. We will use the things we've mentioned in this section, and this will expand your awareness of how widely Maths Lite can be used. I'll see you then.